In this video, we're going to discuss critical steam jet ejectors and variables that will affect their performance. Have you ever experienced a breakdown of performance in your ejector or ejector system? Were you able to accurately troubleshoot and fix the problem? This video will address the most common causes of performance breakdown. Keep in mind, an ejector is a static piece of equipment with no moving parts. In order to work properly, all critical steam ejectors must have a shockwave. When the shockwave breaks down and the ejector's performance degrades, we refer to this as a break or broken. When the shockwave reestablishes and the design parameters are restored, the ejector's performance is regained. We refer to this as a pickup. There are three main issues that cause an ejector to break operation, and they are: first, low motive flow; second, a high discharge pressure; and third, mechanical damage. An ejector is designed with a minimum motive steam pressure that must be maintained in order to pass the required flow. Here you can see the motive pressure and suction pressure on the screen. You can see that this is a well-performing ejector because the shockwave is located in the middle of the diffuser throat. Keep an eye on the motive pressure. When it is dropped below the design value, the shockwave moves into the inlet section of the diffuser and dissipates. The ejector is now broken. How does this affect the suction pressure? This causes a backstreaming of suction and motive fluid, which increases the suction pressure, as you can see here. Once the suction pressure is increased, the ejector flows forward again, only to break. This back and forth may be audible and can be seen in the suction pressure instability. Once the motive pressure is restored to the design value, the shockwave reestablishes and the suction pressure returns to design. The ejector is now picked up. Other conditions besides low pressure that cause low motive flow are higher than design motive temperature, any amount of moisture in the steam, or physical blockage in the motive nozzle. These can all cause a break in operation. The second condition that causes an ejector to break down is excessive back pressure. When the discharge pressure is higher than the maximum design value, the ejector does not have enough energy to compress and the shockwave breaks down. It is important to understand that the ejector does not create back pressure. It is caused by the downstream equipment or piping. High back pressure can be caused by downstream condensers due to high cooling water temperatures, low cooling water flow, fouling, or flooding. Piping pressure drop and system air leakage can also cause increased discharge pressure on an ejector. A slight amount of back pressure may be overcome by increasing the motive pressure. However, this additional motive pressure will add load to the downstream equipment and may cause further increase in discharge pressure. Lastly, mechanical damage to ejector internals can cause an ejector to break operation. Internal motive steam leaks around the motive nozzle or nozzle extension will cause high suction pressures. The motive steam that leaks directly into the suction chamber acts as additional load to the ejector, causing the ejector to ride up on its performance curve to a higher suction pressure. This, in turn, will raise the back pressure on upstream ejectors beyond their design pressure, causing ejectors to break operation. Internal erosion or corrosion of steam nozzle or diffuser will cause deterioration of ejector performance and subsequent increase in suction pressure. Nozzle throat or diffuser throat dimensions that exceed 7% of the original cross-sectional area should be replaced. If the motive nozzle exit diameter becomes out of round or dented, performance will suffer, causing an increase in suction pressure. To recap our discussion, in order to work properly, all critical steam jet ejectors must have a shockwave. There are three main issues that cause an ejector to break down, and they are low motive flow, high discharge pressure, and mechanical damage. For additional technical questions concerning your ejector or ejector system, please contact Graham directly.